Oh my god, I would have been done with this by now, but then I realized I went through this whole thing and my microphone was off. The recording was, I think, 8.5 minutes, so I'll see if I can keep it at that time or less. So we have our molecule here, and I went ahead and drew out, it said, I cropped it off, it said down here that the X substituent was a carboxylic acid, so I drew that there, and then it said the Y substituent was just some kind of amide with some other really weird bullshit going on. I don't care about that. You don't need to know that. So, alright, let's start with the green carbon first that's attached to the X substituent. And I've done some color coding here, so we're going to be labeling the immediate surroundings and secondary surroundings, and I will get into that right now. So we have our central carbon here, and first things first, we have to see what's immediately surrounding it, right? So we have an oxygen right here, and then we have, it's this carboxylic acid carbon right there. And then this guy is also a carbon. Okay, great. So we figured out that this oxygen comes in at number 1. Got that down. Okay. But now we have 2 carbons. So we have to distinguish between the 2 carbons. So we go into what I call secondary surroundings. So on this carbon that is a carboxylic acid, we have an oxygen, and then an oxygen times 2 because it's a double bond. So each bond to an atom counts as if you had one of those atoms. So technically here, this carbon is attached to 3 oxygens. Okay, now this carbon on the bottom here is an oxygen. And then the Y substituent, which is, it's the amide right there, so it's a carbon. That's all we care about right in this situation. So, okay. So now, when we're comparing these 2 carbons, we can see that the carboxylic acid carbon definitely wins over this one because it has a carbon, an oxygen, and there's a hydrogen somewhere in there. Versus 3 oxygens up here. So this is going to be number 2. Up here is X, number 2. And then down here is number 3. Okay. And yeah, so you have your hydrogen sticking out here, coming in at number 4. I don't ever draw those, waste of time. You only need what's important here. So now we just play connect the dots, right? So, and I will get into this dashed bond in a second, but so the way I always distinguish in my head between S and R is how you connect the dots, basically. So you start at 1, you go to 2 and 3. So we're going in a counterclockwise motion, and in order to draw an S, you go counterclockwise, like that. You start off going counterclockwise. So that's how I know it's in the S configuration. Like that, But we have one of our numbered substituents that is not 4. 4 doesn't matter. Number 2 is going into the paper, which basically just means that we have to reverse whatever we see here. We just have to take it and flip it upside down. So that means this S is actually going to become an R. So it's as if this 2 and 3 were flipped. So you would go 1, 2, 3, and now we're going in a clockwise motion. And I remember this is R because you draw R like that. So you just pretend there's a line there and you draw R. You go in a clockwise motion to draw an R, So that's how I keep that sorted out in my head. So this green central carbon that's attached to the X substituent is in the R configuration. Okay, Now we go on to the orange carbon. So again, you start with your immediate surroundings. We got an oxygen here, we got a carbon here, and we got a carbon down here. Okay, same problem where we ran into 2 carbons. Come to that in a second. This oxygen is number 1. Okay, so now between these 2 carbons, we go into the secondary surroundings. On the amide, you again have this oxygen times 2 because of the double bond. Then you have the nitrogen. Okay, now in this carbon on the bottom, you have the oxygen, and then the X it's the carbon of the carboxylic acid, so C. Okay, and again, now it's very easy to see that the amide wins in priority because, well, this double oxygen would win right away based on just what we've got going over here. We're just in 1 oxygen and a carbon, but then also, you know, you add nitrogen onto that, which only increases its priority. So we give that a number 2, which means this is number 3. And we've got our hydrogen now going into the page here, unlabeled at number 4. So because our number 4, which is typically hydrogen, because our hydrogen is going into the page, we don't have to do any kind of flipping here. You know, however we connect the dots is how it's going to be. So you start at 1 again, 2, 3. We're going in a clockwise motion. That is R. That is an R configuration. And that's how you do that.